What does it mean to define? To define is to state or describe exactly the nature, scope, or meaning of. To mark out the boundary or limits of clearly defined boundaries. What is a charter? A written grant by the stakeholders, by which a project is created and its rights and privileges defined. Welcome to IAGNPro's course on Define Phase in Six Sigma DMAC methodology. This course is broken into easy-to-assimilate, just-in-time modules, which are, what is define? Followed by the course on project identification, where we learn about voice of the customer and how they are converted to CTQs. Next is course number 220, project selection, where we learn how projects are selected. Next is course 230, in which we understand stakeholder analysis, who the end users of the project are, what are their interests, how to analyze their influence. This is followed by a course on how to use SIPOC to identify different elements of a process. Next is course number 250, where we describe a charter, its purpose and how to make a charter. Course 260 is on decision-making tools, where we define brainstorming, multi-voting, and nominal group technique, and describe how these tools are used by teams. Course 270, communication tools, in which we explain how teams use agendas, meeting minutes, and project status reports. Course 280 is about quality tools used in the define phase. In define phase quality tools, we discuss how-tos of Pareto charts, cause and effect diagrams, flow charts, run charts, checklists, scatter diagrams, and histograms. Next is section 290, Six Sigma metrics. The Six Sigma metrics explained are DPU, DPMO, RTY, cycle time, COPQ. Course 296 is about communication plans, and finally we discuss how tollgate phase reviews are used throughout the DMAC lifecycle. To ensure that the course stays easy to assimilate, it is made in 3 parts. Let's begin with part 1 of 3, that is Define Phase Part 1. In very simple terms, a Six Sigma project tries to create a process which has 0 defects, by normalizing the process, reducing variation and improving the mean. In DMAC methodology, a practical problem is translated into a statistical problem, which is then solved as a statistical solution. The statistical solution is finally converted back into a practical solution. To understand any phase of DMAC, we should first understand what will happen at the end of the phase. The defined phase will provide answers to some golden questions. First, the selected project, is it in alignment with client goals and direction of business? Have other similar projects been completed? As the saying goes, a problem stated correctly is already half solved. We will get answers about the problem statement. What is the problem? When was it first seen? Where was it seen? And what is the magnitude of the problem? As another saying goes, you cannot improve something you do not measure. By the end of define phase we will know if the problem is measured in terms of quality, cycle time or cost efficiency, and not expected financial benefits. The next question is on the goal statement. Is it measured in terms of quality, cycle time or cost efficiency, and is the financial business case ready? Is project scope reasonable? Have constraints and key assumptions been identified, been addressed? We will also get details of team members. We will also know, who are the customers for this process? What are their requirements? Who are the key stakeholders? How will they be involved in the project? Finally, we will get answers to, how will progress be communicated? What kinds of barriers will need assistance for removal? How will the risk mitigation plan be developed? The ability to successfully deploy a Six Sigma initiative is commonly linked with the selection of the right project. Organizations have limited resources and there is an imperative to achieve multiple objectives and maximum business impact within the constraints of such resources. Hence, when given a large portfolio of projects, organizations and sponsors use various models to help them select the right project and also eliminate subjectivity of human choice from it. Some of these models are Analytic Hierarchy Process, AHP, Analytic Network Process, ANP, Decision-Making Trial and Evaluation Laboratory, DMATEL, Data Envelopment Analysis, DEA. Linear Discriminant Analysis, LDA. These models take factors and subfactors, then detect the different interrelations amongst them. The contributions of the distinct criteria are calculated, and the most effective Six Sigma projects are prioritized and funded. All these models mostly work on a similar approach. These models take factors and subfactors, then detect the different interrelations amongst them. A typical list of factors and subfactors would look something like the visual shown. Also, the impact of the project on the organization level metrics, which are cash flow improvement, client NPS level, operating cost reduction, market share increase, advocacy and loyalty is looked at before prioritizing deployment. Before a project can be selected, it has to be identified. There are two different ways in which organizations do identification of projects. The top-down approach starts from the board of the organization, which does strategic planning. A typical organizational strategic planning process looks like this: creation of a strategic plan roadmap, stakeholder interest assessment, formulation of a mission statement, creation of a business model including funding plans, gap analysis, creation of action and deployment plans throughout the organization using quantifiable performance measures and clear owners and timeframes. This gives us the big why, or the business objectives. After identification of the big why, a natural downward flow of project identification starts. The big why is converted into small whys or project goals. This is followed by setting up of high-level goals, targets, timeframes and owners. Establishing process owners and sponsors, handing over L1 L4 process levels. Every organization has process layers, from L1 to L4 levels. To identify opportunities for improvement, first key L1 processes are broken down to key L2 processes. A typical Six Sigma project then will work on the L2 processes, that is small whys, and show improvement. An L1 layer is strategic business process area, for example project portfolio management, as we discussed in course number 220. The L2 layer is business process area. It is a sub-process of an L1 process, and with distinct but related sequence of process steps. For example, a process in a specific line of business. L3 is activity area, for example how-tos of management and control of the process. The L4 layer is where the tasks are defined. The final steps in a top-down approach are: identify those processes whose little whys are currently not meeting targets constraining higher-level business goals. Start first draft of the charter, and then distribute ideas to project leaders, green belts and black belts, as first draft project definitions. To stay competitive, most organizations now define projects in the processes themselves, not in the boardroom. An organization then decides to ensure every employee has Six Sigma awareness and everyone in middle management is skilled in Six Sigma. Middle management process owners work together in a team to drill down from the original business issues to individual process problems. They use process performance dashboard results and standard Six Sigma tools such as WEOC Research and SIPOC form a pre-analysis. The salient points then of a blended approach are: define projects in the processes themselves. Improvement projects should address specific problems within limited scopes. Engage middle management in the program. Have the process owner be the translator between business and process issues. When you call in for placing an order from an online store, what is important to you? Let's say you have a seemingly simple order for a book, and you state in your order that you want the book delivered in 2 days. Getting the order delivered on time is what is important to you, the customer. But these are expressed from the customer's viewpoint. These are what we call the voice of the customer, or WEOC. These are customer needs and at this stage are not very measurable. WEOC are needs and expectations expressed in the customer's language. They need to be translated. A project is started because a customer needs some problem solved. We need to understand the customer, and convert their needs into quantifiable measures of success. All Six Sigma activities have to start from the customer's voice and the customer point of view, but translated into specific, measurable, attainable, realistic and time-bound goals. WEOC are needs and expectations expressed in the customer's language. They need to be translated. A project is started because a customer needs some problem solved. We need to understand the customer, and convert their needs into quantifiable measures of success. All Six Sigma activities have to start from the customer's voice and the customer point of view, but translated into specific, measurable, attainable, realistic and time-bound goals. Returning to our example, how does the online store convert the customer needs to actionables? The store needs to ensure that all orders are sent with tracking numbers, have the courier report attempted delivery at the expected time, have the customer confirm delivery, and finally ensure that product leaves the store warehouse with enough lead time. This takes the online store from customer needs to business measurable, which are tracking number on all orders, on-time attempted deliveries, delivery confirmation, lead time dispatch. We translated needs from the customer's language into meaningful measurable actions that a business can measure and improve upon. Or in other words, we created CTQs. CTQs are measurable. They measure how good performance needs to be to satisfy the needs of customers. CTQs are the performance characteristics that are critically important to customers. In the business, we can specify how well the business must perform on these metrics to satisfy this customer. We can determine the specifications and targets for these CTQ metrics. With CTQs, you know what metrics to monitor and how well they must perform to satisfy customers. For a Six Sigma project, client needs are collected using basic interview techniques. Let's take an example of an inbound customer service process, in which the client has expressed a desire for change. The possible questions to ask are: what is the main concern of the client with the process? What errors do you observe with the process? What wastes do you observe with the process? Do you feel that there is too much rework in the process? As we had discussed, the answers to these questions will just be the stated client needs. Now we try to convert customer needs into CTQs with the help of a few examples. One of your clients says that the calls must be answered quickly. What could the possible CTQ? It's queue time or wait time. If the client says calls must be answered quickly, what we are going to measure from here on it is queue time, and we will try to reduce queue time. Your vice president comes and says that we have invested in seats and they are empty. What could the possible CTQ be? It will be seat utilization. In the next example, the client says second level escalation should be closed faster. What could the possible corresponding CTQ? Response time. A client says that medical claim documents are not correctly filled. Which metric CTQ would you target? Accuracy percentage. A tech support client has incurred a lot of warranty cost in fixing return to depot products. What do we look into? Cost of poor quality. The next, your client says, we do not process claim documents within the time promised to the customer. The CTQ will be processing time. In the first example, in an effort to reduce queue time, we hire 50 additional resources and bring about the improvement. We will also increase the cost. This is not the objective of Six Sigma. We need to try to maintain this cost constant, and try to reduce the queue time, or we might want to decrease the cost alongside decreasing the queue time. This cost will be called a secondary CTQ, and is a side effect of making improvements to the primary CTQ. A process must focus on the vital few instead of the trivial many. Sometimes it is not easy to arrive at CTQs from customer needs, or the customer's needs generate a lot of CTQs, and we have to drill down to the vital few. For this we use the CTQ tree. Shown here is a sample CTQ tree. After collecting the customer needs, do a brainstorming with your team and ask this question: how can we satisfy this need? This gives the drivers. In this step, rough ideas are okay. Write down all the ideas of your group. Select only the practical ones. For the next column, ask the question: how can we measure each quality driver? There will be multiple answers for the same quality driver. Also, sometimes you don't have any measurable factors and it's okay to use non-measurable factors. However, ensure that you put at least one CTQ for each driver.